Hello class 6, welcome back. Today we are going to start a new unit, a new chapter, that is geometry. Now geometry is basically the study of objects, and the most basic of objects is a point, bindu. Okay, with points, when you combine many points together, you get a line. You might have seen in your smaller classes, they used to give you drawings. Drawings used to be there with points, dots. You had to take your pencil, connect those dots, and when you connect all those dots, all the lines, you would get a diagram. Okay, so like that diagram can be thought of made up of many points. And when you join all those points, you get a line. And when you combine many lines, then you get a plane figure. When you combine plane figures, you get the diagram of an object. So like that, the study of all these terms, starting with point, then it comes line, okay, then plane. These studies are in the field of geometry. Okay, so in your book it says the part of mathematics that deals with the objects such as points, lines, plane and space is called geometry. So since we start with this geometry, so we are going to today see the basic geometrical ideas, or in short, introduction to geometry. And the first topic is points. Now first of all, let us start with the definition of point. I have written over there the heading. Points are exact locations in space. Now look at me, okay? I point like this with my finger on the blackboard. Okay, I say students, look at that part of the blackboard, that point on the blackboard. Nobody will understand where I am pointing, isn't it? But if I go near the blackboard and I say, okay students, look at this point on the blackboard. There, I have drawn with my chalk an impression on the blackboard. That impression on the blackboard is called a point. And this point shows an exact location on the blackboard. Without that point, I couldn't have shown you the exact location where I am pointing with my finger. Okay, that point, if I say without drawing the point, then nobody will understand exactly where I am pointing. But if I go near the blackboard, draw the point over there and say, okay, look at this point on the blackboard. Then the students, all of them will look at that point on the blackboard where I have drawn the point. So point is an exact location in space, and these points can be given names. Okay. And the names that you can give to these points are names of any alphabet of English, okay, capital letters. Okay. Suppose this point, say I give a name as A, and then I draw another point B. So these 2 points are 2 exact locations on the blackboard. So like that, many locations can be pointed anywhere in space, and that particular location can be named by drawing point. So what is a point? Point is an exact location in space. Naming of points, as I have said, you can name any point by giving alphabets, English alphabetical names to the points. Next comes line. Okay, just now I was saying that a line can be thought of made up of many points. Like I have drawn A points. If I connect them, then I get a curved line. It's a curve. Similarly, another set of points. Here, I have drawn 1, 2, 3, 4, 5, 6 points. If I join them, I get a straight line. This is a curved line. This is a straight line. Whether curved or whether straight, these lines can be thought of made up of points. Now let me remind you about one more thing. When we write, whether it's chalk or whether it's your pen, dot pen or ink pen, colors are there in your pen and pigments or particles, chalk particles. You might have seen chalk dust. Here, see on my finger, I have taken chalk dust. If I blow it, the powders, they go away from my finger as I blow. Now these powders can be thought of made up of infinite number of small particles of chalk. So when I am writing, when I am drawing line, these are the powders which are deposited on the blackboard. And in your case, it is the pigment, the color pigment, the pigments of the color of your pen. As you write, those pigments are deposited on the paper when you write it on the paper. So each pigment is made up of one fine particle or one fine dot or one fine point. So when you are writing, you can think of your line that you are writing on the paper as made up of many points. So line can be thought of made up of infinite number of points. Okay, infinite number of points. Each line consists of many points. Like the line that I have drawn with the help of chalk consists of so many particles of chalk powder. Each particle is one point. Okay, each particle is a point. So in geometry, line when we draw, we represent line by only representing its length. We don't say how thick the line is drawn. Like here when I am drawing this line, we don't measure the thickness, how thick the line has been drawn. Rather, we measure how long the length of the line. Okay, the representation of a line has only length. Lambai in Hindi we say, lamba in Bangla. Okay, only length, not the width or thickness. We don't consider the thickness. Okay, now in geometry again, a line is thought of as having no end points. Okay, when I say a line, I don't know how long the line is going to be drawn. Okay, if I say to a student, draw a line on the blackboard, I did not mention him draw a line of say 5 centimeter or 10 centimeter or 5 inch or 12 inches. No, I haven't said anything like that. I said just draw a line. So when I say that, I don't specify any specific length. So we say that a line doesn't have any fixed length, or in other words, a line doesn't have any starting or ending point. Okay, in your book you will see this mentioned on page number 230. Page 230. A line has no end points. A line extends or a line goes on infinitely in any direction. I can draw it as this much length, or I can keep on drawing till this side and this side goes. There is no specific mention about how long a line has to be. So line, when I say, has no specific length, and we represent a line like this. Suppose a line starts from A and goes towards B. So the name of the line can be given as AB, and on top you give this particular sign. Now this particular sign is has two arrows in it. Can you see? Arrow indicates that there is no end. So there is no end towards the left side, there is no end towards the right side. In other words, line goes on indefinitely this side also and this side also. Starting from the direction of A, don't know from where it has started. Going towards the direction of B, don't know how far it is going to go. So lines are represented. This is the notation of line. Okay, line represented this way. Now line can be a straight line, line can be a curved line. Like here I have drawn a curved line, here I have drawn curved line, and a straight line. Straight, not bending this way or that way. Curve can bend in any direction. Okay, curved lines can be this way also. These are combination of two curved lines. Okay. So I hope point and line, these two topics are clear to you. Okay, the next topic that we are going to discuss over here is a line segment. Segment means a piece, a small piece. Now here I have drawn a line. Remember, line has no specific starting point and no specific ending point. And line is represented by this notation. Okay, it starts from say a direction A and it goes towards the direction B. And on top you have this. Okay, arrow on both sides. Arrow indicates that the line extends indefinitely in any direction on both sides. Okay, from this side also, from where it starts, and this side also towards where it goes. No specificity of its starting and ending point. But line segment has a starting and an ending point. This is the difference between a line and a line segment. So in this particular line, I can select 2 points. This point name is A and this point is B. So now, if line is represented by this notation, how will a line segment be denoted? It will be denoted like this. Just like how in line, just like that, but with a little difference. There is no arrow. Remember, arrow says what? There is no specificity of from where it starts and no specificity towards where it goes. But line segment has a specific starting point. That's why no arrow is there. Arrow means indefinitely this side and this side. But here there is no indefinite. There is definite starting point. There is definite ending point. Starting point is A, ending point is B. So line segment is almost similar to line in notation wise when you denote it, except for the arrows. No arrow signs are given on this both sides. So just remember, line segment. What is line segment? It is a part of a line. Just one piece of a line. Line has no starting and ending point, but from that particular line, if you take 2 specific points, then it will have a line segment, and that line segment will have a specific starting point also and ending point also. So this is the difference between line and line segment. Okay, line no starting point, no ending point. Whereas line segment, there is a definite starting point and there is a definite ending point. Notation wise, you denote line like this. We assume that the line comes from a direction A going towards the direction B, and here is the symbol of its notation. A line with 2 arrows. Arrows indicate that it goes on indefinitely in both directions. No specific starting point and no specific ending point. Okay, that's line. In that particular line, if we take 2 specific points, remember, 2 specific locations in space, they are called points. So here 2 specific points on this line. This point is taken the starting point. This point is taken to be the ending point of this line segment. Line segment means a small piece of a line, a small part. Segment means a small part of a bigger part. So from this bigger part line, a small part that we take, or a definite part that you take is called line segment. Okay, and no arrows when you denote it by notation. You don't show any arrows when you show the notation. That means A is the starting point, B is the ending point of this particular line segment. Now we have studied about line, so we need to know few facts or some knowledge we should have about line. First one is, I have already mentioned, a line that you draw has many points in it. When I am writing with this chalk dust or the chalk powder falls off when I rub it with this wall of the blackboard. And when I am rubbing this chalk, can you see the chalk is becoming smaller and smaller? It is eroding from its corners. And where does these particles go? Why does the chalk become small? Because the particles are deposited when I am drawing the lines, when I am writing sentences, then also I am drawing lines. Okay, when I am writing words and letters, I am drawing points. These are actually lines, straight lines, curved lines. Combination of these straight and curved lines make the sentences, the words. And that's where the individual pieces of chalk powder get deposited. So God knows how many number of points, millions of points or dots or chalk powder, dust has fallen when I have written with this piece of chalk over here. So one particular line when I am drawing has many points in it, indefinite number of points. Nobody can count those number of points. So this is the first fact. Second fact about line is unlimited or many, cannot count how many. Unlimited number of lines can be drawn from one point. Now I have drawn one point here, big enough for you all to see. Now from this point, let's see how many lines can be drawn. This is one line. Remember, line is indefinite, so arrows can be given on both the ends. Then another line. Another line. Another line. Okay, you can keep track how many lines I have drawn till now. 1, 2, 3, 4. Okay, let's see how many more can be drawn. 5, 6, 7, 8. What do you think? That's it? No more lines can be drawn? You're wrong. You can draw many more lines. 9, 10, 11, 12. Believe me, we can go on drawing. We can go on drawing. There is no end to lines. You can go on drawing as many as possible. You get tired of drawing and counting, but the lines can go on adding as many lines as possible. There is no end to lines. I am stopping here. There is no point that I draw now. You will not be able to count. But the fact is, unlimited number of lines can be drawn from one single point. Okay, from one point. Oh, many lines can be drawn, and you can still add. You can go on adding. You can go on adding. There's no point for me to go on adding. It's a waste of time. Just for you to understand, I have drawn this. so that you will realize that from one point you can have unlimited number of lines. Okay, the third fact is two lines. You have so many lines, right? But now we are talking about only two lines. Two lines can intersect. What is the meaning of intersect? I'll show you. In only one point. So let us have two lines crossing each other. This is one line. This is another line. Now when we see lines in geometry, we always consider straight lines. If you want to mention about curved lines, then you have to mention the word curve separately. But if you just say line, in geometry, a line always denotes straight line. Okay. So when I have mentioned over here lines, then lines here means straight lines. Keep that in mind. Here also you see so many lines that I have drawn here and there. I mean, crossing this one point. Are these lines not straight lines? Yes, no? They are all straight lines. So when I say line, they all means straight line. Now, what does it say? Two lines. I have drawn here two lines, two straight lines. Intersect. Intersect means crossing each other. See, this line is crossing this line. Or I can say this line is crossing this line. And how many points are there where they cross each other? There is only one point. So two lines can only cross each other at only one point. This is the third fact about lines. Fourth fact. Okay, just below the third fact I have written. Let us read this. The fourth fact about lines is exactly one line can be drawn between 2 points. I hope you understand the sentence. Suppose we have 2 points. Here I have mentioned 2 points. Let's give them name as point P, point Q. 2 points are there. And when I say line, what did I mean? When I say line, line means straight line. So how many straight lines can you draw between two given points? One only, and that is this. Only one line. See, it says only or exactly one line can be drawn between two given points. This is fact number 4 about line. Next about line that we need to know is horizontal line. Horizontal lines are lines which lie down, and we say in terms of geometry, we say those lines which are drawn at 180 degree. Now what is 180 degree? In your protractor, if you have learned in class 5 about protractor, from one given point, this side you draw one line. 180 degree will be another line from the same point which is in the same alignment. In other words, the angle between them is 180 degree. Okay, this way two rays are produced meeting at one point, and the angle between them is 180 degree. Then we say that the line that you get by connecting this ray and this ray is a line which is 180 degree, and this is called horizontal line. Okay, horizontal line. So, do you think this is horizontal line? No, they are not straight. Not straight. This is in this direction. This is in this direction. This is not horizontal. But this is horizontal. So remember, horizontal lines are lines which are at 180 degree to each other. I mean, this is one side, this is another side of the line, and two of them are connected at one point, making 180 degree to each other. So these lines are considered to be as horizontal lines. Horizontal lines. Next is vertical line. Now, vertical line, again we will have to draw two rays. This is one ray. By the way, what is a ray? That also is there in your topic. I think before we start with these, we should know what is a ray. Here also I mentioned two rays. So what is a ray? Ray, here on page 231 they have given, a ray is simply, it has one starting point. Okay, like here. There is one point from where a ray will start and it will go on in any one direction endlessly. Like line, in line there are two ends which are endless. Means we don't know from where it starts and we don't know from, towards where it goes. But a ray, one side is known, the starting point is known to us, but where does it end, that we don't know. Remember, in line is like this. We draw like this. Don't know where it starts, don't know where it ends. So on both ends, arrow is there, arrows are there. But for ray, one side there is a starting point that is known to us, so that is a point. But the other side, the ending point is not known to us. So the ending point, I said, arrow sign is given. So this is called a ray. A ray has a starting point but no ending point. So now, coming back to our topic, that was vertical line. So this ray that we have, here two rays. This is the starting point. From here one ray is going this way, another ray is going this way, and both of these rays make what kind of angle? 180 degree angle with each other. So this is one straight line that you get when two rays are connected. And what kind of line is? Horizontal line. When it makes 180 degree. Now in vertical line, two lines are vertical. Okay, here it should be plural. Two lines are vertical when you have two rays in such a way. See, I have drawn two rays. This is one ray, this is another ray. In such a way that the angle made between them is 90 degree. Okay, then we call these two as vertical lines. Okay, keep this in mind. Vertical line means 90 degree, horizontal line means 180 degree. Next topic is a plane. Now planes are made up of joining at least three lines. Okay, like here, this one line, this another line, this another line. How many lines I have drawn here? Three. And the points of intersection of these three lines are here. And this is the plane. The figure that is formed by intersecting of at least three lines. Suppose there are four lines. 1, 2, 3, 4. Then you have here 4 points of intersection. And this is the plane that is formed by the intersection of these 4 lines. Okay. Similarly, we can have 5 lines also. 1, 2, 3, 4, 5 lines. So we have 5 points of intersection. the plane that you get by intersecting these four lines is this. This is a plane. Now you can go on, number of lines intersecting and the planes that you get. If you see very carefully, our blackboard is also a plane. Let me take my camera a little back. Our blackboard consists of four lines also. One line on the top. There are two lines, one on the top and one on the bottom, and two lines, one on the left and one on the right. They intersect each other and they form a rectangular blackboard over here. Alright. So our blackboard is also a plane. Now with regards to plane, even this is also a plane. This is called curve line. Okay, curve line has been completed and made in form of a circle, or what it seems to be a circle. So the plane that we get over here is this. So this is circular plane or curve plane. So this shaded part or the line part that I am drawing within, that represents the plane. Curve plane, and these are the planes depending on how many straight lines are intersecting. Here a full curve has been drawn. I wouldn't say it to be a circle, it's not a perfect circle, but yes, it's a full curve, and the plane that you get within is a curved plane. Alright? But tell me, is this a plane? Notice all these diagrams, this one and that one. Is there any gap? All these lines are connected. There is no gap, but you will see over here. Here is the gap. Okay, the gap is there between this point and this point. They are not connected. All the lines are not connected with each other. So, if there is a gap, then it will not be regarded, the combination of lines will not be regarded as a plane. So, plane will have all lines connected with each other. There will be no gap. Keep that in mind. So, in regards to that, next topic is open and closed figure. Open figures, this is an example of open figure. Okay, closed figure, this is a closed figure. See, all lines are connected to each other, no gaps are there. There is no gap. Open figure, see, capital U is an open figure. This is the open. So, like that, you can have many figures. In your book, page number 233, right on top of the page, you will see this heading, open and closed figure. Go through that. So remember, closed figures, all the lines, whether straight lines or curved lines, will be connected. No gaps will be there. Open figure, there will be gaps. Closed figure, no gaps. Okay. Next is parallel lines and intersecting lines. Let's start with intersecting lines. Two lines I have drawn here. Now on the left side, I have shown that the gap between the two lines is 5 cm. Then from left, as it moves towards the right, both these lines, the gap reduces. See, now it is 4 cm, next 3 cm, 2 cm. Now I have stopped drawing the line at this point. Suppose I prolong these two lines somewhat. Let's continue drawing these lines. See what happens. 1 centimeter. At this point further down to 0.5 centimeter or half centimeter. And then as you move further towards this side, that is my right hand side, they go and they meet each other. Okay, they come and meet each other. So those lines that meet each other are known as intersecting lines. Okay, even this is also another example of intersecting lines. Two lines crossing each other. This is one line and this is another line. Remember, two lines can intersect each other only at one point. So these two lines are called intersecting lines. Okay, you see here, from here to here the gap is so big. Okay, from here to here the gap is say 7 centimeter. But when you come from this side to this side, now this gap is say only 2 centimeter. I'm just giving an example, maybe not exactly 2 centimeter, but the idea is the gap keep on reducing as it comes from my left hand side towards the right hand side. Again, when it comes here, they cross each other, they meet each other, and when extended further again, as it moves, now the gap starts increasing again. See, the gap is increasing, and here it is the farthest. The two lines are farthest apart from each other. In other words, the gaps between the two lines don't remain the same. This is in case of intersecting lines. And there may come a point when you further extend the line right here that these two lines will come and meet each other. So these are intersecting lines. Now see parallel lines. Best example is a railway track. Two lines here also I have drawn, but the gaps between them remain constant, fixed. Neither increases nor decreases. At this point also the gap is 5 centimeter. In the middle also the gap is 5 centimeter. At this point also the gap is 5 centimeter. So the lines which remain at equal distance from each other, they are called parallel lines. Okay, parallel lines. Whereas the lines where the gaps between the lines don't remain the same and they cross each other at some particular point, those lines are called intersecting lines. Okay, this topic we had discussed a little bit. Let me further elaborate this topic. Ray. It has a starting point. I have drawn here two rays. Let's see about this one. This is the starting point. Starting point is a point from where it starts. You know, point is a definite space in space or definite space in this blackboard. So point from where it starts. Then from this point it goes say in this direction. And it can go to any limit. So here one arrow is given. So that which starts from one point and goes without any fixed length in any one direction, that is called a ray. Now we can again give notation or identification mark of a ray. This particular ray starting point is A and it goes towards which direction? B. So we give like this. Starting point doesn't have an arrow, but towards the direction where it goes, it has an arrow because we don't know till how much it will go. So this is a ray whose starting point is A and goes towards B endlessly in any limit. For this particular ray, starting point is B and it goes in which direction? A. So starting point is B and goes towards A, so we represent it like this. The arrow is in A, above A. In this case, the arrow is above B. Starting point for this particular ray is A, so here no arrow above A. For this particular ray, starting point is where? B. So there is no arrow above B. So this is how we represent ray. Now let us summarize. Line. How do you represent a line? This is a line. Okay. From A direction it goes towards B direction. from A, I don't know from where it originates. So line will be represented. Again here we are going to write AB. AB are just directions, okay, in this case. And line is represented by giving arrow on both sides. This is line. Then comes line segment. Line segment. Now line segment has a starting point also and an ending point also. So starting point is A, ending point is B. So how do we represent line segment? We represent line segment just like this. Starting point is A, so here starting point is A, there is no arrow above it. Ending point is B, so here ending point is B, no arrow is there above it. When do we have arrow? Arrow is only given when it extends indefinitely. Ray has one of its ends going indefinitely. The other, there is a fixed starting point. So above A in this case, in this ray, starting point is B. So above A, no arrow. An arrow is there above that particular point where it goes endlessly. So this is for ray. For line, this is the notation. For line segment, this is how we denote line segment. Okay, line, arrow on both sides. Line segment, no arrow on any side.